Students, welcome to our first class, and this is ISI MSQE 2020 PEB section or subjective section solution. And the first question we have: consider the money lender who faces two types of potential borrowers, the safe type and the risky type, and each type of borrowers needs loan of the same size L to invest in some projects. So the borrower can repay only if the investment produces sufficient returns. Well, that's not fair for the lender. Suppose that the safe type is always able to obtain secure return R from the investment where R is greater than L, and on the other side risky is an uncertain prospect then obtain high return R dash but with a probability of P. So with the probability 1 minus P, the investment backfires and he gets a return of 0. So the money lender has enough funds to lend to just one applicant, and there are two of them. So one is risky, one is safe. So each borrower knows his own type, but the money lender doesn't know the borrower type. So he knows that the one borrower is safe type, the other one is a risky type. That's the only information he has. Since the money lender has enough funds to lend to just one applicant, when both borrowers apply for the loan, he gives loan randomly to one of them. This is very important, randomly to one of them by tossing a coin, assuming that the lender supplies the loan from his own resources and his opportunity cost is 0. So what is the highest interest rate called? This is IS for which the safe borrower wants the loan. What is the highest interest rate for the risky borrower, and who is willing to pay a higher interest rate, the risky borrower or the safe borrower? So here the questions part is very easy. So actually the safe borrower borrows IS if R minus L into 1 plus IS is greater than equal to 0. So which gives so IS equal to, if you just solve it, R by L minus 1. So the risky borrower borrows IR's case is the probability R dash L 1 plus IR plus 1 minus P. So two scenarios, return this and return 0. So this is greater than equal to 0, then only he will proceed, which gives IR is greater than equal to R dash by L minus 1. Since R dash is equal greater than R, so the risky borrower is willing to pay the higher interest rate. So obviously risky borrower pays higher. Next part. The lender's objective is to maximize his expected profit. Argue clearly that the lender's effective choice is between two interest rate IS and IR. Okay, and that is the argue that lender will not choose any interest rate strictly lower than the minimum value of IR and IS, and the interest rate is strictly higher than the IR and IS, and strictly between IR or IS. So this is observing that any I we can take such that 0 less I less IS or IS less I less IR risky. So increasing I is slightly so that it continues to be in the same region. So raising I but still in same range. So this is our target. So this will also increase, this will raise expected profits. Thus I has to be either I equal to IS or I equal to IR. So this is the second part. Now let's move to the third part of the question. In the third part they are saying, argue that when the lender charges IR, his expected profit is given by this equation. Derive the clear argument, the expansion of the lender's expected when the profit charges is IS. So let compute the lender's expected profit at I equal to IS. So that is both borrowers would want to borrow and the lenders which expected profit will be half L I plus IS minus L plus half P into L 1 plus IS minus L. So this is equal to 1 plus P by 2 IS into L and 1 minus P into 2 minus L. So these two are there. So now if we compute these two at I equal to IR, I equal to IR, so at this rate only risky borrower will demand loan at this part. So easier for the lender to decide. So profit P L plus IR minus L equal to I equal to P IR risky into L plus 1 minus P into minus L. That's it. And the last part of it, an equilibrium of credit rationing occurs when at the equilibrium of interest rates some borrowers who want to obtain loans are unable to do so. Okay, lenders do not raise the interest rate to eliminate this excess demand. So explain clearly that we have an equilibrium with credit rationing when this part is there. So such equilibrium occurs when I equal to IS is an and this is the optimal for lender. Okay, so at I equal to IS, this is optimal for lender. So under this condition, from IS to IR, so this happens only when this following structure is applicable. So IS into L and the other part 1 minus P by 2 minus L greater than P IR L plus 1 minus P minus of L. That's it. Pretty basic structure. On simplifying and plugging the above values of IS, IR, we will get the following. Just this part. If you can't able to solve it, write it in the comment section and we will help you with the rest of it.